Welcome to the video lecture series of Theory of Computation. Today we are going to learn about the designing a PDA which accept the language 0 raised to n, 1 raised to n where n is greater than 0. I am your instructor Poonam Patel. Let's start to understand this concept. So here we need to design a PDA for the language 0 raised to n, 1 raised to n greater than 0. Now how we can design the PDA? So for the designing a PDA, first of all we need to take a valid string, and by using this tag how we can compare this values, that we can understand. Now here I have taken a one string which belongs to this language where I have taken n power is 2, so n equal to 2, so the value of string is 0088. Now if you see what valid string contains, so in this language say that those strings which contain equal number of zeros and ones are a valid string for this language, and before ones appear 0 must be appear. So first 0 and then 1 should be appear, so order must be maintained, first all zeros then all ones. Okay, and next second condition is order is fixed, first 0 then 1, and the second condition is the counting of number of zeros and ones must be equal. So that these things we need to take care about it. So first of all what we are going to do, first of all how we can we know that the equal number of zeros and ones, so we have to compare the number of zero with the number of ones. How we can compare? By using this tag. So if you remember, in the formal definition of PDA we have discussed about the tuples of PDA, where we have said that Z0 Z0 is an initial stack symbol, so always stack contain the Z0 initially. Now how we can compare the 0 and 1? So as we know, on a stack we can perform a two operations. A push operation, push means we can insert the symbol onto the stacks, and the next is pop operation. Pop operation means deleting a symbol from the stack. Now by using this two operation I can compare these two values. How? So whenever I read the 0 symbol on an input, in an input, what we are going to do, we have insert all 0 onto the stacks one by one. Whenever I am going to read a 0 symbol, I am going to push it. Now when I start to read a 1 and when I read the one input symbol, what we are going to do, we need to pop the operation. So here you can see I read the first input symbol, this is 0. So what we can do, we can insert this symbol onto the stack. So first 0 is inserted onto the stacks. Now my topmost symbol is 0. Now I read the second 0 symbol. What we are going to do, we have to insert this symbol onto the stacks. Okay, so what we are going to do, so for input 0 we are performing a push operation. Okay, now I read the input 1. What we are going to do, we are now performing a pop operation. So if my input symbol is 1, my top of the stack is 0, what we are going to do, I perform a one pop operation, so deleting topmost symbol from the stack. Okay, now if you see the stack containing only symbol 0 1, only symbol 0. Okay, now again I read the second input symbol, next 1 in a input string. What we are going to do, we are performing a push operation. So whenever I read input 1, I perform pop operation onto the stacks. So again I perform pop operation. Now if you see my input string is completed, reading the input string is completed. So in a PDA, when the input string is completed, the last symbol is considered as a null. Okay, so if input is null and after ending of strings the stack containing Z0, it means that the string containing equal number of 0 and 1s. Okay, so here the comparison between 0 and 1s. Okay, so number of push operation is equivalent to number of pop operation. 0 we have performed a push operation and 1 for a performing a pop operation. So here in this way we can perform and compare these 0 and 1s, equal number of zeros and 1. Now next question is arised. how we can write down the transitions for a PDA. So here you can see, for writing down the PDA operations for a transition function. So as we discussed in a previous video, the transition function, how we can write down the for the PDA. So the transition function contain the first state, the second which input symbol you are going to read, and the next is which state you are which state you are going to move, and what operation you are going to perform. If you are performing a push operation, so for a push operation we have to read the first two topmost symbol after inserting the symbols which you are going to read for a push operation. Okay, and pop operation is defined by the null. Okay, so for this example, suppose I want to write down the transitions. So here right now I am not including the state, but only including the input symbol and push या pop operations. Okay, or pop operations, sorry. So here you can see there are two, n equal to 2, it means that power of n is 2. So two zeros and two ones, so number of zeros are equal to number of ones. So the value which right hand side of this equal to operator, always we have to perform a push operations, and the right hand side we have to perform a pop operation. So number of push, number of pop, if equal to comparison, there should be equivalent. So at the end the stack must contain Z0, only Z0. Okay, now I want to write down the transition. So how we can write down the transition? So here I am not going to consider state. Okay, in next slide we have to understand how we are going to take this state, but right now I am going to take the input, and the next is whether I am going to push or pop operation. Okay, so if you read, sorry, here we have to mention three things: first state, next sigma, it means the input alphabet, and then the stack symbol, topmost stack symbol, what is that contain. And so these three things, and after that which state we are going to move, and whether we are performing a push or pop operation, like this. Okay, understand, these three things we have to mention over here. So how we are going to mention over here? So here you can see n equal to 2. So for a 0, what we are going to do? We are performing a push operation. So my input, here I am mentioning input. Next, topmost symbol, what stack contain before it, and push or pop. These three things, these two things we have. So if my input is, if I am going to read 0 input symbol, if my topmost symbol initially what it contains, Z0, what we are going to do? So for 0 we have to perform a push operation. So how we are going to do? So first insert the 0 on the stack. So now what stack containing top two most symbol? 0 Z0, and we can say that the shortcut 0 Z0, like this. These two things we have. Okay, this is called the push operation. First two topmost symbol, if we have write down right side of this arrow, so this is called the push operation. Now again, now we are going to read the second symbol. This is a first symbol, 0 Z0, insert the 0 onto the stack, like this, insert the 0 onto the stack. Now if I am going to read a second 0, so input is my 0. Now if you see what topmost symbol the stack containing, it containing a 0. What we are going to do? So for 0 input, what we are going to do? Performing a push operation. So how we can write down the push operation? So the reading symbol first inserted onto the stack. Okay, so this second 0 is going on to the stack. Now what stack containing double 0? So directly we can combine these two things, 0 0. So this is called the push operation. Okay, now so again, if n equal to 3, so the same thing is repeated, 3 times 0, 3 times 1. Okay, now if you see 0 0, sorry, 0 Z0, this operation is contained 0 Z0, what it 0 Z0, What we have to do? Push operation 0 z0. Now second 0, topmost symbol is what it containing? First 0 is read. So first 0 input is 0, topmost symbol of stack initial is z0. What we are going to do? We have to insert this 0 symbol onto the stack. So first of all we have to insert it. Now what we are going to perform? This is push operation, so we have to write down 0 z0, first two topmost symbol. Now second 0 is reading. So what is input? 0. Now topmost symbol is what? 0. Now what we are going to do? We have insert this symbol onto the stack. Now what stack containing? 00. Now again third 0 is if we are going to read. So 0 input is 0, topmost symbol is again 0, topmost the stack is always containing, after reading first 0 is always containing, if it is equivalent number of zeros and ones, so it is always containing topmost symbol is 0, so 0. So what we are going to do? We have to insert this 0 onto the stack and 00 like this, first two topmost symbol. Okay, so this is the transition function for input 0 and performing a push operation for an input 0 symbol. Okay, so this is clear. Is there any transition we have to include it? No, only this is repeated, this number of 0 and three number of 3 zeros, 4 zeros, 5 0, 6 0 like this. So this is repeated. Okay, 0 0. So this is my first, this is my second transition for input 0. So we have to write down all the possibility for input 0 for all valid strings transitions. Okay. Now next is 1 is read. So input is 1. What topmost symbol is containing? 0. If it is containing 0, what we are going to do? We have to perform a pop operation. So how we can write down this pop operation? Simply, this is null string, empty string. You can also denote it with the epsilon. Okay, so this is null. So it indicates we have to perform a pop operation. As we know, on the stack, performing a pop operation means removing the topmost symbol onto the stack. So when I am going to read the input, what I am going to do? Delete the topmost symbol of stack. Now my top is this symbol of. Okay. Now again input is 1. Yes, I have write down input is 1. Topmost symbol what it containing? 0. What we are going to do? We have to perform a pop operation. So delete it. Now my pop is this one. Okay, again same here. Okay, second. Now third one is read. Input is 1. Topmost symbol is 0. What we have to perform? Pop operation. So this 0 is cancelled like this. 1 0 null. So now my pop is stack containing z0. So in this way at the end of string is null. So if null input at the end of string, topmost symbol is z0, what we are going to do? We have to now this transition is move to a accepting state. So we have to nothing, we have to do nothing to perform on a stack operations. Okay, so just perform a skip operation and this transition is transformed to the move to the final state. So there are two 0 input, z0 initial state, perform the push operation, the first one for a 0 input symbol, 0 0 00 push operation. Third possibility is for 1, if topmost symbol is 0, it containing a pop operation. This one is 4. So total 4 transition is performed for this operation. So I hope this concept is clear to you, this thing is clear to you. So I hope this thing is clear to you. Now move on to the next one. How we can represent the PDA? It means that how we can construct the transition table including the state. In a previous slide we have discussed about without state considering how we can write down the transition. So here you can see in a transition we have to remember about what input symbol we are going to read, what topmost symbol it contains, and either perform a push operation or pop operations. In a push operation, it read first two topmost symbols, okay, after inserting the reading input symbol, and pop defined by the null. Okay, So here transition table contain 5 things. The first, move numbers, where we have to mention first, second, third, like this numbering we have to give. And second is input symbol, sorry, second is state. Next is what input symbol we are going to read. Third is topmost symbol, what it containing. And the last one, moves, where moves we have to mention two things. The first is state number, which state we are going to move, and the next is either we are performing a push operation. So for push we have to read first two topmost symbols after inserting the symbol, input symbol, and otherwise null, it means indicating the pop operations. And the third one is skip operation. If you are not changing anything on the stack, we have to mention as it is a value of the stack, topmost symbol of stack. So here you can see initially we are at state q0. So here you can see how I can mention, here you can see I have mentioned the state number q0 and the input transition for the 0 input symbol. So right now I am at state q0, input is 0, topmost symbol z0. Which state we are going to move? We are moving the same state q0, 0 z0, push operation, you can see. Okay, now now you have doubt about how many state we have to consider it for this example. So if in example the order is fixed, so what is the meaning of order is fixed? So if you see, before 1 0 must be appear, 0 raised to n, 1 raised to n, it means that all 0 must be appear before a 1. Okay, so what we are going to do, for a 0 input transition, whenever I am reading the 0 input, for its transition I have mentioned on a first state. When I change the transition to a move to the next state, when I am started to read a 1, because for a 1 we have to perform a push operation. So order is fixed. How many values are there? 0, 1, 2 values. So 2 plus 1 equal to 3. It means that for this example we have to use 3 state. Okay, so Q0, Q1, Q2. On a Q0, we have to mention the transition for a input symbol 0. Okay, always remember in a PDA, we have to include all transitions which are involved in a accepting valid string. Okay, if the transition is not given, it means that this string is not valid. Okay, so here you can see 0 state is q0, initial state. Now I am going to read a 0 input symbol. If my stack is initially contains z0, on which state we are going to move? We are going to move a same state. Okay, so it means that we have to construct the self loop. So first is input symbol 0, next is topmost symbol z0, and slash, after slash we have to perform either push operation mention or pop operation. If pop, we have to mention a null. If push, so after inserting 0, what topmost symbol z stack containing 0 z0. Okay, now again, if the input and if input is 0 and topmost symbol is 0, what we are going to do? We have to perform a push operation. So where this transition we have mentioned, the same transition we have mentioned on a self loop of q0. So here you can see, if we are at state q0, we are going to read a 0 input. If my topmost symbol of stack is 0, what we are going to do, we are performing a push operation, and for this push operation can we need to change the state? No, there is no need to change the state. So what we are going to do, we have to use the self loop. Okay, this self loop means either you can repeat this self loop 0 or more times. Okay, according this, so number of zeros is appear, this self loop is repeated. Now if I read a 1, that time I change the state. So on a state q0, if input is 1 and my topmost symbol is 0, So what we are going to do, we are performing a pop operation, and on this, when I am going to read a first one, I am changing the state Q1 like this. Now if any number of ones in input is comes, we have to perform a same transition. Input 1, topmost symbol 0, perform a pop operation. So we have to mention this like a self loop. So if any number of ones is repeated, always remember Q0 to Q1 we have to read only first one, but after first one it may be containing 2 1 3 1 4 1 4 1 fifth ones, like number of 5 1, number 1 is 5 4 5 6 7. So that's why we have to mention on a self loop. So same transition, input is 1 but state is same, so we have to include this step on the transition table. So state is Q1. If we are going to read a 1, topmost symbol is Z0, what we are going to do? Performing a pop operation. Okay. Now, if after repeating these things, if we reach at the final state, after repeating this, if we reach at the null, null means at the end of string mentioned by the null. So, if at Q1, if we get a null and topmost symbol is Z0, what we are going to do? We change the state which considered as a final state Q2, and Z0, the here we are performing a skip operation, always remember, because there is not we are not doing anything on a stack. So whatever the stack symbol before reading the null, it remains as it is after performing this operation, in this operation, during this operation. So Q2 Z0, always remember we have to not changing the topmost symbol of stack. So the whatever the stack containing topmost symbol, we keep it as it is. Okay, so here Q2 Z0. So in this way we can construct the transition table. Now always remember we have to include all the transition which are valid to accept the valid string. Okay. So here you can see, suppose my string is 10. Okay, 1010. So this containing equal number of zeros and ones. But if I am going to trace it, so here you can see, like I am going to raise. Right now I am Q0 state. My input is 1. Now check the transition. Input 1 transition is given. Yes. Okay. Initially stack is what containing? Z0. So input is 1. Topmost symbol is Z0. Now see the transition. Is there any transition which contain this thing? Input 1, Z0, topmost symbol? No. It means that we have, this string is not a valid string, that's why we are not moving to the further state Q1, Q2 like this. So this is an invalid string and we have to reject it. Now consider how we can trace the strings. So here I have considered valid string and check, and let us check whether this string is accepted or not. How we can know that this string is accepted? If at the end of string, if we reach at the final state, it means that this string is accepted by this PDA. Okay. So initially for the tracing string, initially we use the table which shows the tracing of this string. This table containing a four columns. The first mention the moves number. The second column is resulting state, on which state we are at right now. The next column define the unread input. So initially what input is containing we have to mention over here. And the last one is what topmost symbol stack containing. So as we know, initially we are at Q0 state. Our input is 000 111. Initially topmost symbol of stack is Z0. Okay. So here you can see Q0 state, read the input from left to right one by one and take the action and perform and write down the statement. Okay, next row, write down the next row. Input is 0 and top of this stack is Z0. So Q0 state, input is 0, topmost symbol is 0. Now check whether this 2 on a state Q0, 0, Z0 is mentioned here. What it shows, we have to insert this symbol onto the stack. So what we are going to do? This is self loop. It containing, so which state we are going to move for performing this operation? We are moving the same state. So mention this Q0, Q0, 0 is going over here. Okay, so the remaining input after reading 0 is 00, 111. Now this is moves number 1. Okay, now if you see this moves number mentioned in a transition table. Okay, this moves number we are using over here is mentioned on a transition table. Okay, now next input is Q0, sorry, state is Q0, input is 0. Now topmost symbol is 0. So 0 comma 0 on a state Q0. So here you can see 0 0 on a state Q0. Which state we are going to move? Same state Q0. What we are going to do? Moving the 0 symbol onto the stack. So 0 over here, moving over here like this. Now my topmost symbol is 0. Input is 0. Now which state we are going to move? We are moving same state. This 0 is transfer over here, 1 1. So 3 0 over here. Okay, same like this. Now say Q0 state, input is 1, input is 1 and topmost symbol is Z0. So which state we are going to move? We are performing a pop operation and moving on the state Q1. So here you can see Q0 to Q1 we have moved. For a one input symbol we are cancelling this because performing a pop operation. Now what stack containing 00Z0? Okay. Now the remaining is input is, which is unread input 11. So state Q1, input is 1, topmost symbol is 0. What we are going to do? So Q1, input is 1, topmost symbol 0. Now we are performing a pop operation. Which state we are going to move? Performing this operation, moving the same state. So Q1, input, now remaining input we have to write down, and after deleting this, what stack containing Z0 like this. Now Q1 input is 1, topmost symbol 0. What we are going to do? Performing a pop operation. Now if you see, now string unread input is finished. It means that we have reached at the end of string. It means that null input state is Q1 and stack containing Z0. We are moving at final state Q2. It means that at the end of string, now check the state. If it is final state, if yes, it means that the string is accepted. Otherwise, string is rejected. Okay. So I hope this concept is clear to you. Thank you all.